Good morning to all of you. Today we will discuss minimizations problem using graphical method. The name of the subject operations research, course code MBA 205, unit 2. So in the yesterday class, we have discussed maximizations problem and how to solve maximizations problem using graphical method. And today we will discuss how to solve a linear programming problem using graphical method in the case of minimization. So in the linear programming problem, there are two types of problem. One is maximization, another one is minimization. And in case of the maximizations problem, our objective is to maximize certain things, certain parameters in our business decision. And sometimes we are also interested to minimize the cost of various nature. As for example, we can say that the objective of our business, it might be to reduce its cost, how to minimize its cost. The cost minimization is one of the most important business decisions. So today we will discuss how to solve a minimizations problem using graphical method. So first of all, we will go to the minimization problem in your study materials. And after that, we will formulate the linear programming problem from the question. Then we'll proceed to solve that minimizations problem using graphical method. So I hope all of you have the problem. I'm just sharing it, and I will show how to formulate the linear programming problem. So just I'm showing it. So we are coming to the problem number 2. So here is the problem, example 2. And there were certain mistakes we have corrected. So the problem is a particular patient must take at least 60 units of vitamin A, 30 units of vitamin C, and at most 40 units of vitamin B. So we are talking about the requirement of vitamins for a particular patient. So three essential vitamins are A, vitamin C, and vitamin B. Now the question is, all these vitamins will come from two types of diet. That means two types of food. In this question, the first type of food is called as P. The first type of food is called as P. And the second type of food is Q. So from food P and from food Q, we can get three types of vitamin. So one is product P, and other one is product Q. Here product means diet. So patient requires two types of diet. One is product P, another is product Q. And from each product, we can get vitamin A, vitamin C, and vitamin B. Now, two types of diet P and Q are provided to the patient at a cost of ₹20 and ₹10 per unit respectively. So the 1 unit of P product, the cost is 20, and 1 unit of Q product, the cost is 10. So we don't know how many units will be produced. So that's why we are assuming that X quantity of P product and Y quantity of Q product will be produced. So for the production of 1 unit of P, we require 20 rupees. Our cost is 20. So for X quantity of P product, we require 20X. Similarly, for 1 unit of Q product, the cost involvement is ₹10. And our assumption is we will produce Y quantity of Q. Therefore, the cost will be 10Y. So our objective functions will be written in this way. Our objective in this problem is to minimize. What? Is to minimize the total cost. So here we have written minimize Z equal to 20X plus 10Y. So 20X in case of product P, and the cost in case of product Q will be 10Y. Therefore, the objective function we have written here, minimize Z equal to 20X plus 10Y. Right? Now we are coming to form the constraint. Here, just go through this line. If 1 unit of P contains 4 units of vitamin A, so from product P, 1 unit of product P, we are getting 4 units of vitamin A. And from 1 unit of product Q, we are getting 3 units of vitamin A. First, you have to consider the vitamin A. How much vitamin A we are getting from product P, and how much vitamin A we are getting from product Q. So the constant will be, in case of vitamin A, 4x and 3y. Just you look at this point, 4x plus 3y. And the vitamin requirement, vitamin A requirement, at least 60 units. Therefore, we can write in this way, 4x plus 3y greater than equal to 60. Why it is greater than? Because minimum we require 60 units of vitamin A, or at least it will be equal to 60. So one constant is 4x plus 3y greater than equal to 60. Now we are coming to vitamin B. So how much vitamin B we are getting from product P? 1 unit of vitamin B we are getting. And product Q, 2 units we are getting. So 1 and 2, right? Therefore, we can write x plus 2y, and the minimum requirement of vitamin B, here it is written at most. Just remember this point, at most. And here it is written at least. Just these are the opposite word. Therefore, here the constant nature will be greater than, sorry, it will be, just you rectify this point, here it will be less than, here it will be less than. This equation, here it will be less than sign. Just you give less than sign. Where it is less than sign, okay, I will rectify it later on. You will just rectify it, right? X plus 2y, it will be less than equal to 40. Why? Because here it is written at most. That means maximum requirement of vitamin B for a particular patient is 40. Not this is the minimum requirement. But in case of 4x plus 3y, here the requirement is minimum, at least. So the nature will be greater than equal to, or the nature will be less than equal to. So here the 4x plus 3y greater than equal to 60, because at least we require 60, or it means more than 60, there will be no problem. But in case of vitamin B, if it is more than 40 in your body, then it will create some sort of problem. So that's why here it is written at most 40 units. That means maximum requirement is 40 units. Therefore, the nature of constant here, it must be less than equal to. Just rectify this point. Less than equal to. Right? So 40 or less than 40. That is enough. At most. Maximum we require 40. Or maximum we require less than 40. So here the nature of constant will be less than equal to 40, right? Now we are coming for vitamin C. Vitamin C, from product P, we are getting 3 units of vitamin C, and from product Q we are getting 1 unit of vitamin C. In that case, the constant will be 3x plus y, and it will be greater than, because here it is written at least 60 units of vitamin B, 30 units of vitamin C. So in case of in case of vitamin A and vitamin C, the sign will be greater than equal to, and here it is also greater than equal to, but in case of vitamin B, it will be less than equal to, right? So you just correct to the question, it will be less than equal to. And after that, we have written where x equal to number of units of diet P and y equal to number of units of diet Q. And non-negativity conditions we have also mentioned. The value of x and the value of y, it must be greater than equal to 0. So this is the formulation of the linear programming problem in case of minimization, in case of minimizations problem.
Sir, vitamin
Right?
C की equal होवे?
Yeah.
Sir, vitamin C की equal होवे?
Here, in this case,
Sir, मैं 3x plus y equal to 30.
x plus 2y less than equal to 40, not greater than.
दोनों मोटा sir, दोनों मोटा.
In this case,
हाँ sir, वहीटा sir, वहीटा.
3x plus y greater than equal to 30, no problem.
Sir,
Because at least we require 30 units of vitamin C.
अच्छा.
So at least 30. So it might be greater than 30, or it might be less than, it might be equal to 30. There is no problem, right?
Yes sir.
In case of 4x plus 3y, here it is also greater than equal to, because minimum requirement is 60. And if it is more than 60, there is no problem. But in this case, if it is more than 40, there is a problem, because maximum you require 40 units at most. At most means maximum. This is just the opposite word of at least, right? Hello?
Yes sir.
Yeah. Just taking this word line. Huh? Easier to you. Word line. Word line. Yes. Huh? Right? So it will be x plus 2y less than equal to 40. I am highlighting this, less than equal to 40. And in these two constants, it will be 3x plus y greater than equal to 30. This is right. And 4x plus 3y greater than equal to 60. This is also right. Only you correct this sign, this symbol. It will be less than equal to 40, right? So now we are discussing how to solve this problem. How to solve this problem. This is not coming. Yeah. Yeah. So find out now we are coming to this section. So for the solution purpose, all this inequality, it will be converted into equality. It is just like same as the maximization case. So here we have written x plus 2y equal to 40, 3x plus y equal to 30, and 4x plus 3y equal to 60. Equality form. First of all, we have to make it equal. All these equations will be equal, right? Otherwise, we cannot solve the equation. That's why equality sign has been given. Now we are coming to the next point. So how to find out the coordinates? So in case of the first constant, just to go through this, in case of the first constant, what we have written, x plus 2y equal to 40. So both sides we can divide by 40. So x by 40, 2 by 40 means 2 by 40 means 1 by 20. So 2y by 40 means y by 20. And here it is 40 by 40 equal to 1. Right. So the coordinate points, you just write down the coordinate points in this case. Here the x value is 40. So the y value will be 0. So we have written, first we have written x value, then we have written the y value. So 40 is the x value and y value is 0. And here x value is 0, but y value is 20. So x value is 0 and y value is 20. So if we get these two coordinates, 2 points, then if we join these 2 points, then we will get a straight line, right? We'll get a straight line. Just we are coming to the graphical view. Okay. After some time, we'll go to the graphical view. Just we are finding the coordinates at first. So in the second constant, here it is written 3x plus y equal to 30. Therefore, all sides will be divided by 30. So 3x by 30 means x by 10 plus y by 30 equal to 30 by 30 equal to 1. So here we are getting another coordinate points. Here we are getting 10 and y value is 0. So 10, 0. And here x value is 0, but y value is 30. X value is 0 and y value is 30. And which is y-intercept. And another constant 4x plus 3y equal to 60. So again we are dividing 60 both sides. So 4x by 60 means x by 15 plus 3y by 60 means y by 20 equal to 1. Therefore, the coordinate points will be 15, 0 and 0, 20. So we have got 6 coordinates. For the first straight line, we require these 2 points. Second line, we require these 2 points. And third straight line, we require another these 2 points. Now we can construct 2-dimensional graph using coordinate points and identify the feasible region. Now we are viewing the graph so that you can understand it. Yeah. So in the first case, 40, 0. 2 points we have got, 40, 0. So this is 40 and 40, 0. And the second point, 0, 20. 0, 20. Right. So we are getting this straight line. You just draw. We are getting this straight line. You may also draw this straight line right now, because practice is required. So you can also give the name of the straight line. Here we have not given the name of the straight line, but you can give the name of the straight line like A, B. This is A, B. Just to make a graph, A, B. And in the second case, x by 10 plus y by 30. So 10, 0 and 0, 30. 0, 30. So again we are getting another straight line. Just draw it. Another straight line. this one, this straight line, this straight line. So suppose the name is given CD. Here it is C, write C, and here you write suppose M, because D is already given, M. Now after that, from other 2 points, that is X by 15 plus Y by 20. So X by 15 means 15 0. So this point 15 0, and Y by 20, that is 0 20 0 20. So again we are getting another straight line, right? Another straight line. And here we have written 4x plus 3y equal to 60. So here you give another name, suppose A, E, right? This straight line. Now, after drawing all these 3 straight lines, what we are observing here? We are observing here there are 2 intersection points. Here we have got 1 intersection point, and here we have got another intersection point. So first thing, what you will do, you will first do the simultaneous equation. One is 3x plus y equal to 30, another is 4x plus 3y equal to 60. So this is the intersection points. So if you solve 4x plus 3y equal to 60 and 3x plus y equal to 30, then whatever the value we will be getting, that is the value of x and the value of y. That is the value of the intersection point D. It will be equal to 6, 12. That means the value of x is 6 and the value of y is 12. Now we are getting another intersection point, this one. So here the straight line is x plus 2y equal to 40, and this straight line is 3x plus y equal to 30. So again we will solve these 2 equations, x plus 2y equal to 40 and 3x plus y equal to 30. And if you simultaneously solve these 2 equations, then you will be getting the value of this intersection point C, right? So obviously you will solve it after the lecture session at your home. So then you will get 4, the value of x will be 4 and the value of y will be 18. So we are getting value of the intersection point C. So this is your task. So you will simultaneously solve these 2 equations, 4x plus 3y equal to 60 and 3x plus y equal to 30. Then you will be getting the value of this intersection point D, and we have written here 6 and 12. In the same way, you will solve these 2 equations, x plus 2y equal to 40 and 3x plus y equal to 30. Then you will be getting another intersection points value, that is 4 and 18. So after finding the value of this intersection point, we will mark here 15 0, because we know it is 15 0 point and this is 40 0 point, right? No need to find out this value. No need to find out this value. You can take this value 0 0, but no need to take here. this point. Why? Because we have already got a shaded area surrounded by these intersection points. Therefore, will not move to the left side of D or will not move to the left side of C, because our resource will not be permitted. The resource is constant. But in case of the x plus 2y equal to 40, we cannot move to this side. Why? Because at most is given. So whatever the points will lie, so between this range, that means this portion, it will not go to this outer portion, right? So how can we determine these coordinates? Again, I am just saying you, in case of all these 4 points, this point, this point, this point, and this point, which one is the outer points? This point is the outer points. So you mark it. So you will take into consideration. And after that, between these two straight line, we must consider the outer points, not this point. The outer points will be taken. Otherwise, we cannot get this feasible region. And here we'll take only the intersection point D and the intersection point C. Therefore, in this problem, the feasible region will be A, B, C, D, A. So this region is called feasible region. Now we have to check all the points, that is C, D, A, and B in the objective function, because our objective function is to minimize the cost. Now we are going to calculate the value of the cost at various coordinate points here. So value of the objective function is z equal to 20x plus 10y. And extreme points we have considered 15, 0, 40, 0, and these are the two intersection point 418 and 612. And if you put the value of x and y in this objective function, then here we are getting 20 into 15 plus 10 into 0 equal to 300. In the second case, we are getting 800. In the third case, we are getting 260. And in the fourth case, we are getting 240. So out of these 4 values, where the cost is minimum at this coordinate 6 and 12. So if you produce 6 units of product P and 12 units of product Q, then the cost will be minimum, right? So that's why we have written here, we will get the optimum solution at the extreme point where objective function is having the smallest value. This value is the smallest value. The optimum solution lies at the point D with minimum value of objective function, which is 240. Therefore, minimum cost is 240, and maintaining this least cost, diet should contain 6 units of product P and 12 units of product Q, right? So in this way, we may solve minimizations problem using graphical method. But again, I am saying one thing, the graphical method, there is some sort of limitation. We cannot consider more than 2 variables at a time. Why? Because we have only 2 coordinates. One is x, another is y axis. We have 2 axes, not coordinates, axis, x axis and y axis. So along the x axis, we can only measure 1 variable. Along the y axis, we can measure only another variable. So at most, we can consider two variables. If we are considering only two variables, then graphical method is suitable. Graphical method is desirable because we are considering product P and product Q. We are considering two variables. So we can solve it graphically. But when we are dealing with more than two variables, then the graphical method is not feasible. We cannot solve the problem using graphical method. Therefore, we must take the help of simplex method. Right. So in the next class, we will discuss the simplex method, and your task is you will go through this problem, and after that you have to modify the problem. Right. This is the modification. So how this modification is made, that I will discuss in the next class. And after this modification, then we can start to solve the problem. Directly we cannot solve the problem from the question. On the basis of this question, on the basis of the information given in the question, at first we have to make a modified problem, and after that we will learn how to solve the linear programming problem using simplex method. So the next class is very, very important. So I hope all of you will listen this class, the next class. So thank you very much for your patient hearing. So thank you.
Thank you, sir.
Sir,
Thank you, sir.
Stay home and stay safe.